Hello everybody, this is Mr. Joseph, and today we're going to go through lesson 9.1, which will discuss exponents and logarithms. So if I were you, I would try these on my own, but just to make sure you understand what an exponent does, this is your base, and this is your exponent. So this means 3 times 3 times 3, which is 27. This is 4 times 4, which is 16. This is a half times a half times a half. When you multiply fractions, you multiply across. So you're going to get 1 over 8. I'm going to highlight our first weird rule, which is called the negative exponent rule. So negative exponents are a way to represent pretty much fractions. So for instance, 2 to the power 2 is 4. So 2 to the power negative 2 equals, we're going to put this over 1, flip it, and then the negative exponent is going to become positive. So this equals 1 over 2 squared, which is 1/4. All right. Another weird one is 4 to the power of a half. And this is what I'm going to show you this rule. We learned a while ago that if you have a base to a power over a root, this is the same thing as base roots all to a power. So if I erase this real quick, if you have power, everybody, you're on top. And if you think about the roots on the ground, they're on the bottom. So this is 4 because that's my base. My root is 2. And all of this is to the power of 1. And this literally just means the square root of 4, which is 2. For this one right here, it's like a combination of the two. So what we're going to do first is we're going to take care of the negative exponent. So we're going to write 1 over 4 to the power of a half. And then I'm going to write 1 over square root of 4. And this just becomes 1 over 2. All right, one more time. 16 is my base. 2 is my root. 5 is my power. And that goes back to this again. So make sure that you have this in your notes. And so this becomes the square root of 16 is 4. And then 4 to the power of 5 is whatever 4 to the power of 5 is. We'll just leave it like that. All right. So now we've reached like a different set of problems. So these problems are telling you to find the missing exponent. So how many times do I multiply 2 to get 32? This is 5. How many times do I multiply 2 to get 16? This is 4. And once again, you can write 2 times 2 times 2 times 2. And you'll see that's 16. The next question is weird because they're saying 2 to the power of what is going to cause a fraction. So I kind of go through my options. 2 to a whole number makes the number bigger. 2 to a fraction makes a square root. And then 2 to the power of a negative takes something and kind of flips it. So I feel like I know that 2 to the power of 2 is 4. So that means most likely that this is going to be negative because 2 to the power of negative 2 is 1/4. So the answer to this one is negative 2. 4 to the power of what gives me 8? Once again, this number needs to be bigger than 1 because I'm becoming 8, so I'm becoming a bigger number, but it's not like a whole number because 4 to the power of 1 is 4. 4 to the power of 2 is 16. So 4 to the whatever power will give me 8. Well, that has to be a number between 1 and 2. So I don't know if you remember this from integrated math 2, but what we can do here is we can make these two numbers the same base. So instead of writing 4, I'm going to write 2 to the power of 2 with the box there, and then 2 to the power of 3 to represent 8. All I did was write this in an equivalent way because 2 to the power of 2 is 4, 2 to the power of 3 is 8. So the question here is 2 times what is the same thing as 3, I can think about this as 2x equals 3, x equals 3 over 2. And to prove to you that it's 3 over 2, you can do 4 to the power of 3 over 2, rewrite it, and 2 to the power of 3 equals 8. All right? You can do the same exact thing for this bottom one. I'm going to highlight 8, highlight 4, 2 to the power of 3 with a square equals 2 to the power of 2. 3x equals 2, x equals 2 over 3 for that one. Then this one, believe it or not, you can do the same thing. When I think about a half and I think about 8, it's going to be like a negative exponent that gives me a half. So I don't know if you remember, but 2 to the power of negative 1 is going to be a half. And I need my little box there. And then 2 to the power of 3 is 8. So the question is negative 1x equals 3, x equals negative 3. So a half to the power of negative 3 really means like 1 to the power of negative 3 over 2 to the power of negative 3. And then if you flip both, you end up with 2 to the power of 3 over 1 to the power of 3, which is 8. All right? I know I went through those kind of fast. It's supposed to be a little bit of a review, but you can go back, slow down, and then try them again. So the big question today is, what happens when I get a question like 2 to the power of what gives me 15? Once again, 2 to the power of 3 is 8, 2 to the power of 4 is 16. So I know the answer has to be between 3 and 4. So how do I find the exact answer? And this, my friends, we're going to call logarithms, because we need to do the inverse of this statement. Like, how do I get x by itself? So what we're going to do is we're going to write it in logarithmic form. I'm going to explain what it is after, but I'm just going to write down the answer. So we're going to write log base 2 of 15 equals x. And then if we put this in our calculator, we are going to get x equals 3.91 approximately. And if you try this in your calculator, 2 to the power of 3.91 is approximately 15. So in the next slide, I'm going to discuss with you like how to convert it. So everybody, we have something called logarithms, and what logarithms do is they help us find like the exponent that we're missing. So for instance, we had 2 to the power of what equals 15. We know 2 is our base. We know this is our exponent, and we know this is our answer. So if we write this in this equivalent form, I always call it BAY. It's log base 2 of 15 equals what exponent? So in the last problem that we did, it was 3.91. And that's going to be equivalent to 2 to the power of 3.91 equals 15. Let's say you don't like that example. Let me show you one that's a little nicer. Let's do log base 2 of 8 equals 3. Base, answer, exponent. And if we convert that, that's 2 to the power of 3 equals 8. All right? So one thing that we need to know is we've learned about exponential functions look like this. And we've been converting from logarithmic to exponential and vice versa. So the inverse of an exponential function, everybody, is going to be something called a logarithmic graph. So if you have y equals 2 to the power of x, the inverse is going to be log base 2 of x. So I'm going to show you this point right here. Does everybody see that's 0 and 1? So when you do the inverse, it's going to be 1, 0. If I have 2, 4, over here you're going to have 4, 2. Because once again, when you do the inverse, you switch the x and y positions. So now let's answer some questions, and you're going to see it's really similar to what we did. It's just written in a weird way. Base answer equals the exponent. So you don't want a ba, you want a bay. You're looking for the e, which is your exponent. So 4 to the power of what gives you 64. The answer to this, which I'm going to box, is the number 3. You multiply 4 3 times to get 64. Base answer, I'm looking for e. 3 to the power of what gives me 9. The answer is 2. 3 to the power of what gives me 1/9. The answer is -2. All right. I went through those pretty quickly, but this step right here, everybody, of like solving these, is exactly what we did on the top. You just need to understand how to convert from logarithmic to exponential. Your homework is going to be Delta Math 8.1. I'm sorry I can't be with you on Thursday, but I hope you have a great weekend, and please write these notes down and try your homework. Have a good day.